I was asked to do this, and I looked at what was available, and I understand 191 a wee bit this year. Obviously, teaching level 3, I've done that for a long, long time. I won't tell you how long. I look much younger than I really am. I looked at 191, and I've actually got some more interest in 191. My son went through it this year, so I actually have a wee bit of understanding on it. So I looked at these two courses, and what I want to do today is try and show you what's in common and what's different. But I read somewhere that you should start every talk with a joke. So, which one option? Yeah, so there's my joke. So what I did was I went through and I analysed. I looked at the 191. Dave sent me all the lectures. He sent me them as whole PowerPoints, which I couldn't access. It was a nightmare. So I've had all the information, but I couldn't do anything with it. So I managed to do a wee bit, but I've tried to look at each topic, and so what's in red is what's not in level 3. So if you look at the energetics and equilibria, you can see this huge amount of overlap. What's different is Gibbs obviously is missing, and we get down here, we're into this mathematical stuff again. And I found it really, really interesting this morning, and two people have said it now, that the maths is a stumbling block for you. Well, we seem to manage to teach all that stuff with hardly any maths. And our kids come out, level 3 kids actually come out, I'm fairly confident, understanding that reasonably well, and we don't do any maths. And when I looked at what was happening at 191, there was a huge amount of maths in there, and that's going to be really, really hard for the students. I think that's going to be the biggest problem that they're going to have is coming into 191. Those that have done well at level 3 are going to struggle because of the maths, because many of them haven't done this. I've got a student this year, or going to level 3 next year, who hasn't done level 2 maths. Now, if you think about a person who's got, for those of you that are older, the equivalent of school cert maths, and dumbed down a little bit from what it was when you did it, and say, is that student going to be able to understand what we're doing, or what you're doing at 191, or what's happening at 191, the answer is probably no. So we've got to be really, really careful with that maths doesn't get in the way of the chemistry learning. So, yeah, the other thing that came up, and I'll put it in blue, when we talk, I'm not sure if I'm the only one, but I've never ever talked about the solubility quotient. Does anyone out here talk about the solubility quotient? You talk about ion product? Yeah, I'm going to get one nod. So again, it's a terminology thing. So there's interesting issues there with terminology, and I think that as a group, when you think about the numbers that were quoted before, that I'd looked at last year in 2007, about 4,000 students did level 3. So 4,000 students did level 3 and 1,500 students did Chemistry 191, and 1,100 students did the equivalent paper at Auckland. These are the ones we're talking to, and we should make sure that we're at least using the same terminology for the same thing. I mean, I don't care whether you call it solubility equation or ion product, maybe the purists do in some way, but I think we need to make sure that we are using the same words, because otherwise we're going to make these kids confused when we don't need to. Acids and bases, again, huge amount of overlap. Again, this maths comes in terminology. We use the ideas of Henderson-Hasselbalch, but we don't. I've never used that word. I discovered that word when I was, well, that name for the equation when I was reading these 191 lectures. So, do we need to use it? I don't know. Perhaps we should start using it if it's being used at 191. Lewis acids, we don't do Lewis acids, but they are in 191. And degree of dissociation, again, that's just a mathematical concept. We talk about degree of dissociation in terms of this is lots dissociated or this is not much dissociated. And suddenly in 191, they're asked to put the numbers in the equation, they're all at percentage dissociation. Why? I think it's the question that, does that matter? Is that amount of maths important? It's just another bit of maths that we put in, or that's been put in to make it perhaps a little bit more difficult than it needs to be. Maybe it makes it easier to answer or write examples. Biological molecules, I think this is where we started to fall apart in a big way. We've got the same words, but that kind of finishes there. We introduced these functional groups, and again it comes up with the carbon chemistry module, that we introduced those words, but the depth here is much, much greater. So there's 3 new functional groups. Lithium aluminium hydride reduction was that. We don't even talk about it. The bright kids realise that reduction's a possibility, but we kind of just move on. We don't. And sulphur and phosphorus containing functional groups are completely foreign to level 3. We don't do any of that. Yeah, there's overlap to a point, but obviously the depth that's in 191 is huge compared to what's in level 3. We really don't go very far at all. We're just that introductory. It's just, this is what's in there. This is these things. We identify all those functional groups. A little bit of chemistry around it, but very little. Transition metals. We used to do lots when I first started teaching. I won't say. But when I first started teaching, we used to have, I used to do probably 6 weeks on transition metals, and I really enjoyed it. The kids loved it. You got lots of pretty colours, and you played with complexes, and there was lots of good practical work we could do. But that's all fallen out. Now, all we do with transition metals is we say those things. Formation of complexes, variable valence, coloured compounds, and we also mentioned that they are often used, if I move it out of your camera, that's good. We often use it, well, I say it's catalysts. I just copy and pasted this straight from the first lecture slides on organometallics, and you can see there's a whole lot more there. And again, the level, the depth here is huge. There's all those lectures basically would be new to any student coming to 191, even if they had done level 3. I have to say that it scares me that kids are coming into 191 without having done level 3. I think they'd be under sync. I think that someone suggested we should have some system. I think you should just be writing prerequisites. It seems to me that if you haven't done level 3, you're going to find this incredibly difficult. And if you've got students who haven't done level 2, they haven't got a work sketch chance. Redox chemistry. A little bit more detail, but we do cover most of it. You can see this almost complete overlap there with those 2 courses. Until we get into the maths bit again. And things like the Nernst equation. Well, what? It was interesting helping, because I'm a chemistry teacher and my son was doing it. Of course, I was running tutorials, by the way, Dave. I was doing work for you. I had a table, my kitchen table was surrounded by first year 191 students going, I don't get this, and it was normally I don't get the maths. And it was things like the Nernst equation. Log is a button on a calculator. It means nothing more than that. And so, if you've got something with those kinds of functions in it, they're out of the depth. Organic chemistry, again, as I said before, same list of functional groups. But that ends it. We do really simple reactions. The reactions, again, we cover the same reactions, but no mechanistic detail. These are the reactions, really, really simple. Addition, Markovnikov's rules as far as we go. Basic acid base, we say that like carboxylic acids are acids and they do things that acids do, and amines are bases and they do things that bases do, but we don't look at the organic acid reactions. We just talk about them as acids or as bases, and the same kind of way.